Alright, this video is going to be going over the practice sheet that I gave out in class on the 14th, well, which is today. I assume this is the only time you're going to watch it, so yeah, I'll say it's today. So, number one was the average velocity of the object. Let me make this bigger. Alright, was the average velocity of the object from t equals 0 to t is equal to 3 seconds. And this really just goes hand in hand with your knowledge of the formula is that, well, if you have an average velocity, well, what's your displacement? My displacement after 3 seconds is 3. My time is 3. So I get 1 meters per second. Done. During which time interval is the object at rest? We know that if we have a PT graph, if you're staying at the same position, let's call this 5, we know that you're at rest, you're not moving anywhere. If at 5 seconds you're still at 5, you're not moving anywhere. Alright? So if you see a slope of 0, you're not moving. 0, and this is only true on PT graphs. 0, VI 0, at rest. Well, I wouldn't just call it VI, let's scratch that average velocity. So what will happen? What looks like a straight horizontal line where you're not moving? Well, 2 to 3 seconds. So it's answer B. Question 3. What is the velocity of the object at t is equal to 1 second? I'm not going to really make this not going to trick you on the test. This is kind of tricking you right here. Well, the line is kind of in between 1, 1, 2, so it's kind of like there, and so it's like 1.5. So the answer would be D, 1.5. There's another way you could have done this without even estimating. Since you know that this line right here, again, this line right here is constant, that must mean my velocity is the same all throughout this line. My slope is constant. That must also mean my velocity is constant. So I could have just calculated the slope here where I was sure of the position. So I could have just done v is equal to 3 divided by 2, and I still get 1.5. So that's a proper way to do it. That's probably how they wanted you to do it. But hey. But hey, you know, that's how it goes. Gotta take shortcuts sometimes. Oh yeah, on the test here, if I ask you to show work, you're not taking shortcuts. Alright. So how far is the object from the starting point at the end of 3 seconds? At 3 seconds, my displacement is 3 meters. So I am 3 meters away from my starting position because my starting was 0. Answered 4. Perfect. So question 5 is something I discussed in the motion graphs conversion video. You're looking at the motion of all these objects. So let's look at choice A. PT. Constant slope. Constant non-zero slope on a PT graph means you have a constant velocity. So a VT graph, if you have a constant velocity, you're staying at the same number. Let's call this 5. You're staying at the same number, constant. It's the same. So choice A is correct. Let's explore the other choices. Let's explore the other choices. This is negative slope. Negative slope going downwards. So you have a negative constant velocity. Negative constant velocity. The VT graph being shown, this right here is that your velocity is changing. So you've already disproved this can't be the answer. And if it was a negative velocity, it would be below the x-axis. Except you have a positive velocity. Your velocity, your line is above the x-axis, so positive velocity. So already disproved that These two things are different. Also, this is not constant. It's changing as acceleration. So B can't be the correct answer. So choice C. What choice C is saying is that your position is at 5 meters forever. So you have velocity of 0, no slope, no slope. But what the VT graph here is saying is that your velocity is changing. You actually have a velocity, changing velocity. And so this cannot be true. Let's look at PT. Let's look at this. So this one, again, you have a changing. Oh, you have a constant slope. And so that must mean you have a constant velocity. And in this graph, this VT graph right here, you see that it's a changing velocity. So if this is 0, this is 1, and this is 2, you'll realize that your velocity changes over time. And so this is a changing velocity. So this cannot be true. These two aren't equal to each other. So the only choice is choice A. Number 6. Number 6. What distance time graph best represents the motion of car B during time interval t is equal to 0 and t is equal to 60? What you'll see in this velocity time graph, well, rather the speed time graph, is that the car B has a straight line. And so let's call this 30. So that must mean that over time, my velocity is always 30. So we can say that it's a constant speed. What kind of PT graph represents a constant speed, right? If you have a constant speed, that must mean you have a constant non-zero slope. So you have a constant non-zero slope. That must mean that this is the only choice. Is this constant non-zero slope? And we know that slope on a PT graph is your velocity or speed. Again, velocity is just the scalar version of, the vector version of speed. And I already explained the other, what those other graphs mean in the other videos. So number 7. During which time interval is given below, which car traveled the greatest distance? And we know that in a VT graph, the area in between, I need to stress this, in between the line and the x-axis is your distance or displacement. Distance or displacement. Perfect. So the question is basically saying you can translate this as which car has the greatest area during which intervals has the greatest area. So let's look at choice A. Car A from t is equal to 0 to t is equal to 30. Well, you only have one triangle. That's your area. Let's look at the triangle. Choice B. Car A from t is equal to 30 to t is equal to 60. Car A from t is equal to 30 to t equals to 60. So you have a triangle. And then you have another square underneath. So this entire area is a distance traveled. Let's look at choice C. Car B from 0 to 30. 0 to 30, just have a square. Just have a square. And choice D. Car B from t equals to 30, t equals to 60. You just have a square as well. So when you're looking at all these areas, which choice gives you the greatest area, the greatest distance traveled? And so the only choice here is B, choice B. Feel free to pause before, feel free to pause somewhere. Now at 8, question 8, how long did after t is equal to 0 did it take car A to catch up to car B? So they catch up when they reach the same distance traveled. Uh, you didn't really have to do math for this. Maybe you could have, but but hey. So they catch up when they reach the same distance, and we know that distance, your area is your distance in a VT graph, in a VT graph only. So if you look at choice A, it says 10 seconds. Well, if you look at 10 seconds, car A's area is that, the tiny triangle right there. That's the area of car A, and car B's area is that. It's goddamn rectangle. So there's no way that's possible, right? Car B traveled a greater distance in 10 seconds than car A. Car B, car B is 20 seconds. Oh no, choice B is 20 seconds. Well, the triangle's a little bit larger now. Triangle's a little bit larger, but car B still has a larger square or rectangle. So B can't be it. B can't be it. A can't be it. Let's look at C. C at 30 seconds. So, well, the triangle got larger this time, but car B, the area underneath car B is just a square. So car B is still traveling a greater distance. Car A still hasn't caught up yet. Let's look at D. Let's look at D. 60 seconds. Well, this is where it starts to make sense. And if you want to confirm, you can just do the math. Just take out this block. If you look at the areas for both, you see that this triangle right here is equal to this rectangle. And you can do the math to just double check. But this is how I like to do. I like taking shortcuts. So you see a square here, which matches up to this square. And if you split this other side up into two sections, you'll realize that you have two triangles as well that equal to this triangle right here, and this triangle, and this is like that. So the area is equal, and so when the area is equal, they catch up to each other. Number nine. How far did car A travel in the interval between t equals 0 to t equals 60? How far did it travel? Well, you're taking the area again. You're taking the area of this entire triangle. And so this is 60. This is 60 as well, and this is 0. So we know the area of a triangle, 1/2 base times height. 1/2, 60, height, 60, and you get 1800 meters. All right, that's the answer. Choice C. Number 10. Oh, mistake. Number 10. What is the acceleration of car A during the interval between t is equal to 0 and t is equal to 60? So what is your acceleration? You know that your slope. You know that your slope of a VT graph is acceleration. So just calculate the slope from 0 to 60. What's my change in x from 0 to 60? 60. What's my change in y? Well, what's my change in y from 0 to 60? It's 60. My change in x from 0 to 60 is also 60. And then I get a slope of 1 meters per second squared. Choice A, that's the answer. 11. Which graph represents the motion of object traveling with positive velocity and negative acceleration? And so if we have a positive velocity, that must mean we are traveling the positive direction. So your displacement, or your position, is going up, right? If we look at this graph right here, and this is 0, let's extend it, p. It's negative and positive. We have a positive velocity. It must mean we're going in this direction, the positive direction. The next part is figuring out, well, do we have an acceleration? Yes, we do. We have an acceleration. So if we have an acceleration, have sorry about my handwriting, have acceleration, that must mean we have a changing velocity. And if we have a changing velocity, that must also mean we have a changing slope. Changing slope. That must mean that our line here should be curved. And then this really just leads to the answer. You don't even need to know about whether or not it's speeding up or slowing down. If you know that your slope should be going in this direction, well, hold on, in this direction, and you know that your slope is changing and you know your line should be curved, well, it's a matter if it's this way, you just figured it out. It's in the positive direction. It's also curving. So the only choice is B. If you look at D, choice D has a negative velocity. You're going in the opposite direction. So there's no way choice D could be it. Choice A and C can't be it because if you have an acceleration. If you have an acceleration, your line on a PT graph is curved. Straight line means constant. Curved line means changing slope. Let's go further into why this is the correct answer. If you have a negative acceleration, if you have opposite signs, you're slowing down. Opposite signs, slowing down. So which slope looks like it's coming to like a horizontal line? Which slope? This slope, of course. Are you getting fast, 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 slow, until you come to a rest, until you come to a horizontal line. All right. Number 12. Number 12. Which pair of graphs represents the same type of motion? Well, I think I've covered this multiple times, so let's go over it again. Just one last time. Changing slope. Changing slope, and this is a PT graph. So on a PT graph, your slope is velocity. So that must mean you have a changing positive velocity. It's positive because you're going up on the position. So you have a changing positive velocity, and you look at your VT graph, doesn't make sense. Your velocity is changing velocity, changing. And I'm not going to write slope here because it's not slope. You have a changing velocity, just constant slope. But we know that a constant slope, a slope on a VT graph, your slope is acceleration. But this is the only thing you need. These four boxes are the only thing you needed. You didn't need to know this too. Just need to know this. That's the only possible choice. Let's look at choice B. Negative, positive. Basically what this is saying is that you have a positive slope, positive, and let's actually represent this quickly. Positive slope, we know that a slope on a position time graph is velocity. So you should have a positive constant velocity. And so what does the VT graph saying? The VT graph is saying you have a negative velocity. So that can't be true. Sorry about rushing through this. I just kind of just want to finish this real quick. So you have a PT graph here. It's going down. So negative slope. It's also a constant slope, constant non-zero slope. And then this must mean you have a constant negative slope. Oh boy. Oh boy. It's negative, zero, positive. Oh, I'm sorry. Just undo. No, I'm good. So you have a straight line right there. Well, if you have a constant slope and your constant negative, well, this should be velocity. Constant negative velocity, you're just gonna have this. You should just have your velocity time graph would just be this. Say this is -2. That would be representing this. But this is a changing velocity, and there's no way this can be true. Let's look at choice D. Choice D is easy way to look at this. Changing slope, changing velocity, which means changing velocity. And if you look at your VT graph, you'll see that, well, is this a changing velocity? No, this is a constant velocity. And so there's no way this can be true. Alright, end the video. Hopefully that didn't take too long.